Have you ever had a moment where reality felt off? Like when you walk into a room and your brain just resets? Today, we're going to find out if that's just you being human, or if it's the system dropping frames. In this video, first we'll look at the strange pixelation of our universe. Then, I'll show you why video games might be the key to understanding physics. And finally, the scariest part, if we are in a simulation, who is running it? Elon Musk once suggested the odds of base reality might be incredibly small. That's a wild claim. But the idea itself isn't just Silicon Valley hype. It's been seriously debated for decades. Simulation hypothesis. The idea that our reality is an artificial simulation, likely running on a supercomputer by an advanced civilization. Base reality, the real physical world where the computer running our simulation actually exists. Our universe appears to be pixelated at the smallest scale, just like a computer screen. At the Planck scale, our current physics starts to break down. Some theories suggest space-time could be granular, but we don't know yet. Just like a screen is made of pixels, some physicists believe the universe might be built of tiny, indivisible units. This suggests that reality could have a resolution limit, which is exactly what a digital rendering engine uses to save processing power. Honestly, every time I look at my hand, I wonder, if I zoomed in deep enough, would I see skin cells, or would I eventually hit the pixel grid? It creates a potential limit on how detailed our world can be. It's a terrifying but fascinating thought. But here's where it gets weird. If the universe is a computer, how does it handle all that data? The universe might behave like it only locks in details when something is measured. Not because a human is watching, but because a detector forces an interaction. In video games, this is called frustum culling. The game engine doesn't render the city behind you until you turn around. In physics, we have the observer effect. Quantum particles like electrons exist in a state of probability, a wave function, until they are measured. Only when we measure them do we get a definite outcome. It behaves suspiciously similar to a game loading assets only when the player enters the zone. Einstein famously asked, "Do you really believe the moon is not there when you are not looking at it?" Now, this doesn't prove reality is rendered like a game. It's just an analogy. But it makes you wonder, is the code just waiting to be executed? But even if the physics is just a coincidence, the statistics are much harder to ignore. Bostrom's argument suggests that if advanced civilizations can run simulations, we might actually be in one. Philosopher Nick Bostrom proposed a famous trilemma. He argues that one of three propositions is true. Civilizations go extinct before becoming post-human. Post-humans have no interest in running ancestor simulations. We are almost certainly living in a simulation. Think about it. We already create simulations like The Sims or GTA. As our computers get faster, these games could eventually become indistinguishable from reality. If that happens, and if civilizations run billions of these simulations, then the number of simulated worlds would vastly outnumber the one base reality. So if you accept these assumptions, the odds that you are in the original base reality become incredibly small. You could just be a history project for a student in the year 5000. Now I know what you might be thinking. Simulating everything down to every atom sounds astronomically expensive, maybe even unrealistic. But remember point 2? They don't have to simulate everything. They only have to simulate what we experience. They don't simulate the inside of a distant star until we point a telescope at it. It's an optimized build, and that's exactly why this matters. It means the system is designed for us, the observers. Before we conclude, you might ask, can we prove it? If space really is a simulation on a finite computer, there should be signs. Physicists are looking for lattice artifacts, distortions in high-energy cosmic rays that would mirror a grid structure, or compression artifacts, where the laws of physics simplify at extreme scales to save data. We haven't found them yet, but we are looking. We've looked at the pixelated grid of the Planck length, the efficient rendering of quantum mechanics, and the overwhelming statistics of Nick Bostrom's argument. The clues feel suggestive, but none of this is proof. So are we living in a simulation? We don't know, and we might never know. But the fact that the question won't go away is exactly why it's worth exploring. But perhaps the real question is, if this is a simulation, does it make your life any less meaningful, or does it mean you can hack the game? If you found this fascinating, make sure to subscribe and hit the notification bell. And tell me honestly, if you found the exit door, like in The Truman Show, would you walk through it, or would you stay? Let me know in the comments. Until next time, stay curious.